Hey everyone, wanted to make a quick video to go through the content so we don't fall behind. I do want to remind you this will not be on quiz 3. This content from this video is simply so we can rearrange the schedule a little bit and keep all the work days and keep the day before Thanksgiving and all that sort of good stuff. So I wanted to keep things as streamlined as possible. So that said, we're going to be talking about data management. And to start off with, we think about the video that we watched earlier in this semester, one of the first videos we watched in this class. And it was about how companies learn your secrets. And in that video, it talked about Target. It talked about how Target is effectively able to gather information about customers and how they're able to analyze that data. And they're able to get insight about customers and how they may or may not be using some of their different platforms and stuff, and specifically how Target is able to look for customers who are pregnant. And based off of that, they're able to build models that promote products to those customers to help get them in the sort of Target mindset. So with that said, what we want to keep in mind is sort of talking about how this is useful for companies, because there's a whole world for companies to be able to effectively explore as they relate to data. Okay, so we have the analytics perspective, where we're trying to figure out how to better market and sell products to customers. We have the perspective or data for keeping stuff for regulatory reasons, keeping stuff for internal improvement reasons, keeping stuff to where we can quickly and efficiently know insights. That's really the key behind why data management is important here. So having said that, we want to think about the concept of big data. So there's 3 V's, and that's V as in Victor. Those V's sort of help us discover and think about what big data is and how we can quantify and define it. So first we have V for volume. Okay, so volume is saying how much space does this data set take up? We can express that in some derivative of a byte, be it a megabyte, terabyte, gigabyte. Any of those are going to be measures of the volume of the data. We have variety. Variety is looking at seeing how much variation there is within the data. So essentially for that, what you're doing is you're looking and seeing from one data point to the next, how different are they? You know, in a lot of data sets we've been working with in this class, there's not a ton of variety in them. You know, you look in the quality column, you expect every value of that to be quality. It's not different images, it's not different videos, it's not different other things we see with big data. And then velocity is looking at how rapidly new data is being added. So in some cases, data is added once a day. In some cases, we add data once a week, once a month, once a quarter. In other cases, though, data is added in real time, and it may be added multiple times per second, sometimes hundreds or thousands of times per second. So those 3 things together make up big data. It's data that's very large in volume, very varied, and also has a high velocity. It's constantly having new things added to it. So having said that, how do organizations effectively keep up with all of this? Well, so organizations use databases. Databases are similar to spreadsheets we've been using in this class with a couple differences. And the main differences between a spreadsheet and a database is that with a spreadsheet, there's some pretty staunch disadvantages to it. So a spreadsheet is one single file. And that file can be shared with multiple people, that's true, but then you have to give the person basically full access to the spreadsheet. With a database, you can restrict parts of the database. Say, for example, you had a person table inside of your database. You could give someone access to that person table without giving them full access to parts of it that are particularly sensitive, like a social security column. You could restrict that. You could restrict a date of birth column. You could restrict different accounts to not have access to the person table at all. You just have a lot more flexibility with who can access what, who can edit what, and all of that. Databases also get rid of a lot of redundant data that spreadsheets would have, and we'll touch on that a little bit more in the coming slides. But understand also that with databases, unlike a single spreadsheet that has one version of it that's the so-called current version, a database, you can have multiple people making changes to it, and due to the nature of how it's stored, people can make simultaneous changes without any issue, unlike a spreadsheet. And then on top of that, something we haven't touched on quite yet, but we will a little bit later in the semester, is the fact that with a spreadsheet, we cannot have more than 1,048,000 rows inside of an Excel spreadsheet. We cannot have more than 10,024 columns inside of an Excel spreadsheet. Those are inherent limitations to a spreadsheet. And we don't really have a great way around those, but with a database, it's very common that we have millions and sometimes billions and maybe even trillions of rows worth of data, which is an incredible amount for us to think about, but that is something that we see. So there's a lot of advantages that databases have, although there's also some drawbacks. And those drawbacks come from the fact that databases tend to be a lot more difficult to work with, particularly if you don't have the knowledge behind them. Now, having said that, this is an intro class. This is not a data management class. This is not a database major or anything like that. This is just getting you aware of what databases are capable of doing. I don't expect you to leave this class an expert in working with databases. We do have additional courses that if you're interested in, you can certainly take. A lot of people in Terry are interested in analytics. And one of the courses in the analytics pathway that a lot of non-MIS majors take is the Database and Analytics course. So that is MIST 4610. You could definitely take that if you're interested in learning more. There's also a plethora of resources online you could look at. I'd be happy to share some of those with you individually offline if you want. There's tons of textbooks available. There's online resources you could look in LinkedIn Learning for stuff with SQL, but I don't want to bore you with all that. Okay, what I do want to do is take a look at this example here. What we have is we have a cars table on the left side and we have a customers table on the right side. And rather than linking the owner of those cars, so we don't have to put their name, their date of birth, their gender, we don't have to put all that inside of the cars table. What we do instead is we have what's called a key. You'll see where it says foreign key there. And that is linking to the customers table. So we have customer 135, and that corresponds with the ID from the customers table. So if I wanted to know who owns this car, what is their first and last name, I can simply look at that join, and then that'll be able to tell me that. So I don't have to have that information 50 times or 500 times or however many times this owner might be inside of this database. Now in this particular example, not too many people own 500 cars. So you might think that's kind of silly. But imagine an example where you had a transaction log for a grocery store. You scan your ID that has the rewards or whatever for the store. Well, that's tied to a person. So if you had a table of all the transactions, imagine the savings. I don't know about you, but I purchase hundreds and thousands of different products every year at the grocery store. And whenever I do that, if that's entered into a database, it doesn't really make sense to have my customer information entered in there thousands of times. It should be entered in there one time, and you tie it together with that foreign key. So that's what the foreign key is there for. So having said that, what we do focus on in this class is not the nitty-gritty, but the general sort of modeling data. So what we want to think about is what's known as the logical data model. And in the logical data model, what we want to do is we want to come up with a way to take our database and model it. This is where we're going to come up with all the tables, all the columns, and we're going to basically design the database. So one thing to keep in mind is that we refer to this as the relational database model. The reason it's called the relational database model is because this has relationships. Okay, so let me throw some terms at you here. You have your entity. Entity is going to be the noun. And basically, this is what you're making a table of. So if we go back a couple of slides here to the example that we had for the cars and the owner, those are both entities. Okay, so we can think of entity and table as being the same thing for all practical intents and purposes. So those entities have relationships with other entities. So a car has an owner. That is a relationship. The car has an owner. The owner has cars. So that's how those relationships sort of work. So basically, what we have then is we have columns. We want to describe the owner. So we have columns. We have a first name, maybe a last name, a middle initial, a social security number, a date of birth, a phone number, an address. These are all columns that would appear inside of that owner entity. For the car entity, we might have columns about the car. You know, we have the make, the model, the year, the color, maybe mileage, that sort of thing. And then you'd have probably a column in there for the owner ID to tell who owns it, to be able to link those two entities together. So then we go from there and we look at the records. Now, records inside of a table are just going to be the row. Okay, so you can think of that as being an instance of the entity. It's an actual occurrence of the entity. So if we had that car, the row inside of the cars table is going to be an instance of the car entity. Now, having said that, on a relational database model, we don't show rows. We don't show any of the records. We don't show any of the specific actual instances. We keep it to the entities and the attributes. So again, I'm throwing a lot of terms at you now. They are listed here, and basically attributes are just those columns. Okay, that's all that the attributes are. So to recap, entities are tables. Records are rows. Attributes are columns. So I know that that's a little bit different, and it is a little bit confusing at first that the relational database model has different terms than the database itself. But if you don't get too caught up in that, you should be fine. So having said that, we have an example here of a data model. And you can kind of see how this works, okay? So you have listed here, you have a course, it belongs to one department. Department has many courses. Then you have your course and the course grades. So someone takes the course, they get a grade on the course. It corresponds with both the person who took it and the course they took. And you can see that the person might have an office assignment. The office assignment belongs to a person. You can kind of see how those relationships are working there. So like I mentioned, the entities, these are going to be those singular nouns. This is what we're collecting information about. So for your company, you're going to come up with entities. And you might come up with an entity for customer. You might come up with an entity for product. You might come up with an entity for location. You might come up with an entity for store. The sky's really the limit for what you come up with, but ultimately, it's going to be stuff that you can come up with different examples and different attributes for it. So we take a look here at these entities for movie, character, production company, and actor. So we're going to be coming up with attributes for each of those. Okay? So that said, I know it's not Valentine's yet, but it's always a good idea to learn more about relationships. So when we have entities, we mentioned that we have relationships. Now, in this class, we don't spend a lot of time focusing on the specific different types of relationships. But what I want you to understand is that there are different types of relationships that we may see occur inside of a data model. So we might have a one-to-one relationship. And if we go to our next slide, we'll see exactly what that can look like. But we might also have one-to-many or many-to-many. So we take a look here between character and actor. So what we're saying here is that character has many actors. In other words, a character can be played by more than one person. We're not limiting one character to be played by one person because over time, different actors tend to fill the same sort of character roles. And then an actor is certainly not limited to playing one and only one character in their career. So it's called the crow's foot here. Okay, it's got the little 3 things going off from it, 2 things going diagonal, 1 thing going straight. That's the many symbol. We look at movie and production company, we see between movie and production company, that's a 1-to-1 relationship. We're saying that a movie has one and only one production company. But then if we go from production company to movie, we're saying that a production company has one-to-many movies. Okay, so that's basically what we're sort of seeing there is we either are dealing with one and only one, or one-to-many, or many-to-many. So movie and character is a many-to-many because on both sides we have a many. Character to actor is a many-to-many because on both sides we have a many. And then movie and production company is not a many-to-many because one side has one and only one, the other side has one-to-many. So that's basically what's going on there. So we could take this and split this up a little bit further and come up with some different attributes that are going to go into production company, movie, character, and actor. So we will do that in just a little bit, but for now, what I want you to understand is that these attributes are going to become the columns when we make the actual database. The data model is saying, this is what we will put in the database. The database is the actual database. So one thing I did not mention yet is the primary key. So a primary key is an attribute. Okay? They're not mutually exclusive. A primary key is still an attribute. And it is an attribute that uniquely identifies each instance, or in other words, each row of the entity. So it should be something that's unique. And some examples listed there are social security number, student ID number, perhaps a phone number in some cases, although with home phones and business phones, those can be shared. But it's just something that's going to uniquely identify every single instance, or in other words, it's going to uniquely identify each row of the table. So we take a look here. We've come up with some different attributes for each of these entities. We have production company, movie, character, and actor. And we identify the primary key by first putting it at the top of the entity. So we have company ID, movie ID, character ID, and actor ID. Those are all the very first attribute listed for the entity. And second way we identify the primary key is with an asterisk. So we put an asterisk beside to say, hey, this is the primary key for this entity. And you can see the other entities that are listed there. We have production company, company name, company address, company city, company state, company zip, movie, movie title, movie year, character, character name, actor, actor first name, actor last name. So you can see all that information for each of those different entities. So, we talked about a foreign key briefly. Now, foreign keys and primary keys are not the same thing. Foreign keys are what we put when we want to have a join between the tables. And primary keys uniquely identify every record in the table. So that's really the difference there. If we think back to the car and the owner, we had the owner ID inside of the cars table because I wanted to have a way to relate the cars table to the owner's table. And that's what the foreign key is there for. It's something to have in common so that you can do a join between the two tables. So we take a look at this data model here, and we've added in some foreign keys. So for the production company, we added in movie ID as a foreign key to be able to relate production company and movie tables to each other. And you can see that we specify the foreign key just by saying FK after. This stands for foreign key. So, that said, that's the example that we showed, and you can kind of see how this cars table and the customers table are related with that owner ID foreign key inside of the cars table. So really, you need to have a foreign key on one side of the relationship. Now, again, I can't really emphasize this enough. In this class, when you're working on the data modeling project, we don't grade it for accuracy. Look, if you meet the minimum requirements, I promise you, you will get a 100. If you meet the minimum requirements and you do not get a 100, let me know. Unless it's late or something like that. I mean, late penalties are separate from that. But that's graded on a participation basis. I always say, we're not trying to steal points from you. In this class, I don't think it's reasonable for me to expect you to be an expert data modeler. I don't think it's reasonable for me to expect you to be able to, completely do a data model from scratch. That's not something I think is reasonable. I want you to be thinking in the mindset about what exactly, you are going to be using this for in business. Because it's used wildly, not just in MIS, but in accounting this is used, in finance this is used. You're going to use this in looking at real estate data in some cases. We have insurance cases that use this stuff. So databases are an important thing for you to understand what is possible. So having said that, we're not going to have any test questions over structured query language. That's what SQL stands for, a structured query language. But I do want to go through these examples to show you what is possible. Because that's my focus for this class, is on getting you interested, on seeing what is possible, on being able to be an executive who understands what is possible to ask for from people who specialize. Or if you choose to specialize, getting interested in it early. So we have the movie and the character tables listed here. And basically what we're doing is we're doing SQL select statements to pull information from these tables. So a SQL select statement starts off with select, and then you say from, and the from is going to be the table or tables you're getting it from, and then you have where, and you can specify any conditions that you want. So what this first statement does, it selects the movie title column from the movie table, where the movie year is 1996. What that is going to do in English is that it's going to return every movie title that has the movie year at 1996. So you'll get a list back of all those. The second select statement selects the movie title from the movie table, but here, instead of just grabbing every movie year that is 1996, it grabs the movie title that contains Star Wars. That's what this like, and then inside of quotes, and you have the % sign here, that's saying if it contains the word Star Wars, return the movie title of it. So in English, that is going to return the movie title of every movie in the database that contains the word Star Wars. Now third, you have where you're selecting the movie title from the movie table, where the movie ID equals the character.movie ID, and the character name equals Skywalker. What that is going to do for you is that is going to return the name of every movie that contains a character in it named Skywalker. So that's some of what you can do with SQL. There's a lot more you can do with it. Like I said, I'd be happy to share some resources with you about that. But for the majority of you, I understand this isn't something that you're really dying to use, and that's totally fine. It's not necessarily about understanding every finer detail in this class. It's more about understanding how to manage technology and how to use that technology to have a successful business, to have operations, to have stuff run efficiently. That's the focus of this class. So having said that, your assignment that you're going to be doing for this final piece of the 5 assignments is your data model. What you're doing is you're coming up with at least 3 entities. And these entities, again, they can be anything relevant to your business. It could be employee, it could be customer, it could be sale, it could be transaction, it could be location, it could be item, product, anything you want to do. And for each of those 3 entities, you're going to come up with at least 3 attributes that describe the entities, as well as a primary key for each of the entities. So that's the minimum. You can definitely go beyond that, totally fine. To get credit though, make sure you have 3 entities and 3 attributes for each entity and 1 primary key for each entity. Now, you also want to include relationships between the entities. So you can do one-to-one if that makes sense, one-to-many if that makes sense, or many-to-many. You're just going to model that out. And there's examples in the slides that should help you out with that. You're also going to model foreign keys on at least one side of it. So basically, just pick an attribute that can act as a foreign key on at least one side of it. And look, here's the thing. Look at this second to last bullet point. It doesn't have to be 100% accurate, okay? Like I said earlier, I promise you, if you meet these minimum requirements, it's not graded on accuracy, it's graded on completion. So just meet the minimum requirements, you'll be good, submit that by the due date, and that's going to get you at a good spot with data management. We'll have a work day to work on this during class. I'll be in the classroom that day to answer any questions. I do hope this video was helpful for you. I hope you have a great rest of your day. Look forward to seeing all of you on Friday.